Hello, I'm Dr. Chanak Vijayaratna, the CEO of the Sri Lanka Olympiad Mathematics Foundation. I'm going to discuss the SLMC 8 2020/21 paper. This paper should have been held last year in 2020, but we could not hold it because of the COVID pandemic. So we held it this year in 2021, and that's why this is labeled as 2020/21. Now, in the Sri Lankan mathematics competition, you get 30 questions, and you have a 90 minutes duration to answer the questions, multiple choice questions. Now, the first 10 are easy, and the second 10 are medium, and the third 10 are hard, right? And also the points given to the questions in these three sections, right, they reflect the difficulty level of the questions. Now, in the first 10 easy questions, right, you get 5 points for correct answers and 2 points for no responses and 0 points for incorrect responses, right? Okay, so let's look at the first 10 easy questions, right? So let's start. So let me erase this and move this sheet to the side to get space, right? So, okay, let's move it here, right? Let's enlarge it so that you see clearly, right? Right, 100%, right? Now we are all set. So the first question, which of the following numbers is closest in value to 3 to the 2020 plus 0.14159 to the 2020, right, from the given numbers, right? So now you can see that now all the choices, right? Now, if you look at this number 0.14159, this is a number less than 1, right? So when you multiply it with itself, it gets smaller and smaller, right? So this number is actually less than 1, right? But we can get a better estimate by this way, right? Now this is less than 0.2, right? And if you raise this power to 2, right, we have this, okay, square less than 0.2 square, right? And this is actually 0.04. And if you take the third power, right, this is less than 0.2 to the 3, and this is equal to 0.008, right? So you can see that this gets smaller and smaller, right? So this will be a very small number, right? So if I draw a real line, then mark 3 to the 2020 here, right? and then this number, right? This number would be very close to this 3 to the 2020, right? Now, where is 4 to the 2020? Of course, it is bigger than 3 to the 2020, but how much bigger than this 3 to the 2020? So what is this? The difference between 4 to the 2020 minus 3 to the 2020, right? We can also estimate this, right? So I can write this one. So this is bigger than 4 to the 2020. And now here, instead of 3 to the 2020, right, I replace this 2019 of these 3's by 4. So we get 4 to the 2019, right? And then from this, I can pull out 4 to the 2019, right? And I get 4 minus 3. So this simplifies to 4 to the 2019, right? So you can see that is a huge number, right? So the answer to this question is A, right? Now, what I did here, right, all these calculations are not necessary in the competition, right? So you will feel that, you should feel that that the answer is A by just looking at it, right? So this is, what you do when you solve these problems leisurely, okay? Okay, let's go to number 2, and then let me erase this. Right, I got them rounded up and cut it, right? And number 2, we need to find out the remainder when 7 to the 2020 is divided by 2. Now, when we are asked to find the remainder, right, then actually it is not the long division, right? In the long division, the remainder is always 0 because either the long division stops, right, or it continues forever, right? So this is actually not the long division, right? We don't go into fractions, right, in dividing. So we can write, so here actually we use this. So let me give you a little bit of theory here, right? So if we have 2 integers, right? Now integer set, we denote by the symbol, right, is set. So this is integers. And we also have the symbol is it plus for positive integers. Right? So here A and B. So A belongs to Z, an integer, right? And B belongs to Z plus, right? A positive integer. Okay. So when A is divided by B, right? We can write A as QB, right? Where Q is a quotient, right? Plus the remainder, right? Now here, this remainder, either it is 0 or it is less than B, right? So this remainder can be, so what are the possibilities? It can be 0, it can be 1, 2, up to B minus 1, right? Now this 7 to the 2020. Now 7 is an odd number, right? It's an odd number. That means we can write 7 as 2n plus 1, where n is an integer, right? Now, if you take an odd number, right, we'll divide an odd number by 2, right? So the remainder is always 1, right? So now this 7 to the 2020, right? So this odd number is multiplied by itself, right, 20 times, and the result is also an odd number, right? Because we know that odd times odd, right, is odd, right? So therefore, when this number is divided by 2, the remainder is 1, right? So the answer is 1, right? Okay, so let's go to number 3. So let's erase all this. Right. So number 3, we are given this calculation, right? 3 times 5 to the 2020 plus 7 times 5 to the 2020 minus 9 times 5 to the 2020. Now, you know that you're not going to, you should not be calculating these huge numbers 5 to the 2020, right? Instead of that, we're going to use a bit of algebra, right, to come up with the answer, right? So we can pull out 5 to the 2020 from these numbers. So we get 3 plus 7 minus 9, right? So this is actually 1, right? So this is 5 to the 2020. So you can see that with a bit of algebra, we could find the answer very easily, right? Sorry, that's not the answer. The answer is C, 5 to the 2020. Right, good. So let's go to the next question. So this number, which has 12 digits, right? So when this is divided by 2, right, we are asked to find the quotient, right? Now you can see that this is an even number, right? So when we divide this, actually, even the long division will stop, right? So we can actually divide this using the long division and find out the quotient, and then count the number of digits in the quotient, right? So now 2 goes 6 times into 13, and then we subtract 12 from 13, you get 1, and then you bring down this 3, you get another 13, and then 2 goes 6 times again into 13, so we get 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, right? So if you do the division, you will get this quotient, right? And this quotient has how many digits? It has 11 digits. So the answer is 11, right? So it is the response A. Now we can also do this in a different way without doing the long division, right? So as I said earlier, when we solve these problems leisurely, we should look for alternative solutions, right? And we can give a nice alternative solution here without doing the long division. Now for this, we're going to estimate this number, right? So I'm going to give it a label, right? This number. So let's say this is x, right? So x is less than, so I'm right here 2 times, right, 10 to the 11, right? Now 10 to the 11 is the number, right, which has a 1 and then 11 zeros following that one, right? So x is less than this, and x is bigger than 10 to the 11, right? Now I can divide this inequality by 2, right? So then I have 10 to the 11 divided by 2 less than x over 2 less than 10 to the 11, right? So this x over 2 is actually this quotient, right? Okay. So so x over 2 is between these two numbers, right? Now this is the smallest number, right, which has 12 digits, right? That has 12 digits, right? And this one is, right, it is equal to, now 0.5 times 10 to the 11, that's not the way I should write it, right? So it is like this, and this is 5 times 10 to the 10. 10 to the 10 is the number that begins with 1 and then 10 zeros following it, right? So this number has 11 digits, right? Now, since these are all positive integers, right? And if this guy is in between these two numbers, bigger than an 11-digit number and less than the smallest 12-digit number, then this also has to have 11 digits, right? So we got the same answer, but we didn't do the long division. So this is an interesting alternative solution, okay? Okay, so let's go to the next question, number 5. So let me get rid of all this. Right. So in number 5, we have this figure given in bold lines, which is made of 6 equilateral triangles, and what you get is actually a regular hexagon, right? So regular hexagon, right? So regular means that the regular polygon is a polygon, right, which is equiangular. That means all the angles are equal, right? For the regular hexagon, that means all these angles are equal, right? Equiangular. And also equilateral, right? A regular polygon is equiangular and equilateral. So that means all the sides are equal, right? That means so these 4 sides are equal, right? So this regular hexagon, right, is inscribed in a rectangle, right? And we are given the area of the rectangle, right? And we need to find the area of the hexagon, right? in terms of the area of the rectangle. So, the rectangle is like this, right? And if you divide this rectangle, if you draw lines like this, right, you can see that this rectangle, right, consists of so here right, it consists of 16 congruent triangles. Congruent triangles. Right? Now here is one triangle. So let me use a different color. So here is one triangle, right? Now here is another one, right? So likewise, there are 16 congruent triangles. Now congruent means that, right, similar in shape and size. Congruent. Similar in shape and size. So that means if you cut these congruent figures, right, then let's say that you draw them on paper and cut them out, you can superimpose them, right? So now out of these 16 congruent triangles, right, the hexagon, right, consists of how many of them? 12 of them, right? 12. So the area of the regular hexagon, the figure in bold lines, right, as a fraction of the area of the rectangle, it is this, right? So this is 3 over 4a, right? So the answer is C, right? Okay. So let's move on to the next question, number 6. Okay, number 6. So there are 6 cards in the box numbered from 1 to 6. And you pick 2 cards randomly. How many different values can the sum of the numbers on the cards take? So now you can see that the smallest number, right, the sum of the 2 numbers can take is 1 plus 2, right, 3, right? And the largest number the sum can take is 11, right? Now between 3 and 11, right, how many numbers are there as for the sum of the 2 numbers? So we have 4, it is 1 plus 3, and 5, 1 plus 4, and 6, 1 plus 5, and 7, 1 plus 6, and 8. We can have, this as 5 plus 3, and 9 as 5 plus 4, and 10 as 6 plus 4, right? So we have all the numbers between 3 and 11, inclusive of 3 and 11. So then we have 11 minus 3, which is 8. So 8 plus 1, right? 9. So we have 9 values. So the answer is 9, right? Okay, the next question. Next question, Kamal and Meena, they go on a trip, and then Kamal spends 8 rupees, right? And Meena spends twice that much, right? So for the total cost for the trip is 2A plus A, 3A, right? And for each person, the cost should be 3A over 2. Now, Meena spent 2A, right? 2A minus 3A over 2 is A over 2, right? So that means Meena spent A over 2 amount more than her share, right? So that means Kamal has to give this much to Meena to make the amount of money spent equal, right? Equal share, right? So the answer is A over 2, right? B. Right. Good. So now number 8, right? So let me erase all this. Right, number 8. In a school, the ratio of girls to boys is 6 to 5. The average height of the girls is 121 centimeters, right? So the average height of girls is 121 centimeters, and the average height of the boys is 132 centimeters. So now we can say that there are 16 boys, 16 girls, and 5 in boys, right? For some positive integer n, right? Now the ratio is 65, so it could be 6 girls and 5 boys, right? It could be 12 girls and 10 boys. It could be 18 girls and 15 boys, right? So we can take that. So the 6n girls and 6n boys, right? So if we have 6n girls, right, then the sum of all the heights of girls would be the 6n times the average, right, which is 121. And then if there are 5n boys, then the sum of the heights of all the boys would be 5n times 132, right? And then if you divide this by the number of students at the school, which is 6n plus 5n, right? You get the average height of students, of a student, right? So what is this? So we get 6n times 121 plus 5n times 132 over 11n, right? We can cancel n, right? Now, cancel means that, we pull out n from the numerator, right? So then we get 6 times 121 plus 5 times 132, right? And then canceling, right? And not only that, we can pull out in, we can pull out 11, right? Because 11 goes evenly into 121 and 11 goes evenly into 132. So if you pull out 11 in, right, it would be here 11, here 12, right? And then you can cancel this 11 in and 11 in here, right? Then what do you get? You get 6 times 11 plus 5 times 12. So this is 66 plus 60, which is 126. So the average height of a student is 126 centimeters, right? So the answer is B. Right. Let's go to the next question, number 9. So let me erase all this. Some left over. Right. So number 9. We had to find the value of 1, 2, 3, 4, 5, 6 times 6, 5, 4, 3, 2, 1 minus 1, 2, 3, 4, 5, 5 times 6, 5, 4, 3, 2, 2 plus 134. And you should have the feeling that you're not supposed to do this calculation directly, right? You had to find a shortcut, right? And if you think a moment, right, you can see that there is a shortcut, right? You can write this 1, 2, 3, 4, 5, 6 as 1, 2, 3, 4, 5, 5 plus 1, right? So this number plus 1, right? And then you can write 6, 5, 4, 3, 2, 1 as 6, 5, 4, 3, 2, 2 minus 1, right? So this number minus 1, right? And when you do that, right, you can easily simplify this, because when you expand this, right, and expand it, right, you get this times this, right, and that and this get cancelled, right? And then you have 1 times this, right? And then 1 times this, and then 1 times -1, right? So you have now this 6, 5, 4, 3, 2, 2, and this minus 1, 2, 3, 4, 5, 5, right? And then this, right, minus 1 plus 134. So what do we get here? So we get 12 minus 5 is 7, and so here what this 1 here, 11 minus 5 is 6, so 2 here, 12 minus 4 is 8, and 3 minus 3 is 0, 5 minus 2 is 3, 6 minus 1 is 5. I hope this is correct. You can actually do it here if you want. 6, 5, 4, 3, 2, 2, 1, 2, 3, 4, 5, 5. So 12 minus 5 is 7, 11 minus 5 is 6, 12 minus 4 is 8, 3 minus 3 is 0, 3, 5, right? And then minus 1 plus 134. So you get 5, 3, 0, 8, 6, 6 plus 1, 3, 4, and this is 0, 0, 9, 0, 5, 3. Is that correct? Right, 0, 0. So this has to be 0, right? And this should be 1, right? So it is 5, 3, 1, 0, 0, 0, right? So do you have such an answer here? Yes, C, right? Okay, so let's go to the next question, number 10. So let me move this, right? And let me erase all this, right? Right. Okay, number 10. So we are given a net of cube, right? And then we are asked to find the number opposite 3 if the cube is made using this net, right? So let me draw this a little bit from a different angle, right? So this is 3 and 6, like this, 6. And this is 5, and this is 4, and 2, and then 1, right? So if you make the cube, right? So let's say this is the face containing 3, and then you're folding like this, right? So then this face would contain 6, right? And then so this face would be what? So that's actually would be now this line, right? This line, right? It goes like this, right? And then you fold like that. So you can see that it is actually 5, right? On this side you get 5, right? I think for a moment it is correct, right? And then now where is 4, right? So the 4, so it is like this, right? So here's 3, right? And then you have 3, 6, right? Now this line is actually, so let me draw it, this line, right? It is actually this one, right? And then 5 actually, right? So when you fold it like this, right? You have, like this, right? Here. So this is 5, right? And then now where is 4? Now 4 is here, right? 4 is here. So this is 4, right? And then you fold it like this, and this comes like this, right? So this H and this H will coincide, right? And then this line, right, it comes here, right? So that means this side, right, the bottom would be 4, right? And now what is this line? So this is actually this face, right? It is 2, right? This face 2, right? And then so this is this line, right? And then it goes like this, right? So this on this side you have 1. Okay, so I think with a bit of visualization, you can see that the answer is, right, 4, right? So it is 4, right? So that's the end of the easy questions, right? So now we go into medium questions, right? So I'll start discussing medium questions in my next segment. Okay, so thank you.